Hello, and welcome to this lesson on factoring special patterns. So this is another continuation of the previous couple lessons on factoring trinomials, although we won't be seeing many trinomials in this lesson. So this is just another branch of factoring, other types of problems you can look at and try to factor. So if you could please pause the video and see if you can find the mistakes in those two problems. Hit play when you're ready to go. All right, so this first problem here, I like the first terms. I mean, I'm looking at, if I was factoring this myself, I would start with a 2x and an x just like they did. I like the last terms, the 5 and the -3 does equal -15. My concern is that the middle two terms don't work out. That is a 5x, that is a -6x, and you know what? That one looks good. I don't think there's a mistake there. Let me double check. 2x and x is 2x squared. Positive 5 minus 6 would give us a -1x. And positive 5 minus 3, nope, he's good. That one is actually correct. No mistake. Let's see here. Well, there's lots of mistakes already. 3x times x is not 6x squared. Positive 4 times by positive 1 is not -1. So I don't even know where to start with that one. So the correct factoring would have to be a 1 and a 1. And then factors of 6 would be 1 and 6, 2 and 3. Both 2 and a 3 and a 1 and a 6 could make a 5. So I'm going to start with the numbers that are closer together first. And let's see. 3x. I can see this is the wrong set of numbers. This one's not going to work out. And 2x, because in order to make these both positive, to make a positive 5, I'm not going to get a -1 here. Like, everything works out except 1 times 1 is not -1. This is the wrong set. It's not going to be the 2 and the 3. It's going to be the 6 and the 1. So this will be a positive, and that's going to be a negative, which means that should be a -1 right there. And now everything works out. We get a 6x squared. This would give us our positive 5x, and our last right here would give us our -1. Now, there's not really a vocabulary here. So if you remember a few lessons ago, there was a lesson on when we were multiplying special patterns, and we had those sum and difference patterns and square patterns. And I told you at the time that don't really worry about them, just multiply like normal. Well, this is the time that if you took the time to memorize those patterns, that they may come in handy. But you know, my advice for you is exactly the same as it was going to be before. Don't worry about trying to remember this pattern or these patterns. I mean, heck, who wants to remember all this junk? If you continue factoring like I've shown you the previous two lessons, this is going to be very quick and very easy, and nothing really to cramp your styles. Like, check out this first problem. We want to factor that thing. Now, you might be looking at going, that looks a little different. We don't have a middle term. There's no y, no just plain y term. Okay, that's what's missing here. Now, if we try to factor this like normal, boom, ba-dum, 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 my factors of 16 are 1 and 16, 2 and 8, 4 and 4. My factors of 4 are 1 and 4, 2 and 2. But more specifically, the 4 and the 16 are both perfect squares. They are numbers that I can take the square root of and get a perfect answer. And that's a clue for us that this may be kind of a special factoring. Now, if I was going to factor this normally, I would use this pair and that pair anyways, you know, the numbers that are closer together. And in this case, because these are both perfect squares, that's probably the right thing to do here. Check this out. I'm going to get an 8 y and an 8y. And how would we make our middle term cancel out? How do we make this become a 0y? Well, that's if one of these was a positive and one of these was a negative. And that's it. My middle term had canceled out because one was a positive 8y, the other was a negative 8y. Combined together gives us 0y. And everything is good. 2 times 2 is 4. Positive 4 times negative 4 is negative 16. Okay, so if you continue factoring the way I've shown you, you don't have to worry about remembering all those patterns and things. Those patterns, if you wanted to memorize them, are kind of a shortcut. But this long way is really not that long, and it's familiar. Both of these numbers are perfect squares, which tells me it's probably going to be 3 times 3 and 2 times 2. I can't guarantee that, but that's what this lesson is all about, showing us that if these numbers are both perfect squares, that's probably going to be what's going to happen. 6m, 6m. Again, you'll notice in here there is no middle term. There's a 0m. That's because one of these is positive and one of these is negative, and your middle term cancels out. That is our answer. Now, if I try this and I check this and the math doesn't work out, I mean, if for example, let's say this is a plus here and positive 2 times negative 2 does not equal positive 4. Well, then I'm going to try some other things. I might try a 1 and a 4 or a 1 and a 9 and try some other patterns. But if they're both perfect squares, or if you're listing your factors, 1, 4, 2, 2, you're going to try the two that are closer together first anyways. That's going to be like your shortcut to the answers here. All right. One more for me, and then one for you to try. So letter C here. Ooh, those numbers are not perfect squares. 8 and 50 are not. But my brain tells me that those numbers are both even. If I would factor a 2 out of these, those numbers are both perfect squares. So I can say, you know what, that's a 2 times by a, I'm going to guess a 2p and a 5. Again, my middle term is going to cancel out. There is, make it a little smaller. There is 0 p's right there, because one of these is a plus and one of these is a minus. And if I check my work, that is 4p squared. I'm looking at this guy here. 2p times 2p is 4p squared. Negative 10p, positive 10p. They cancel out and give us the 0p for our middle term. Negative 25. This is my factors. I've factored this as much as I can. And it's okay to leave this extra 2 hanging out here. If this was an equation and set equal to 0, instead of just pulling this 2 out front, I would have divided by 2 on both sides and just eliminated that 2. So he's not a problem we have to worry about. But we do need to hold on to him, at least for now, because all of this stuff in the end should be able to re-multiply back out to the original expression. All right. Letter D. Why don't you go ahead and pause the video and do this one right now. When you are ready, continue, hit play, and we'll go through it together. Both of those numbers are perfect squares. That is 11 times by 11, and that is 13 times by 13. So when I am doing this, I can see the writing's being a little slow on the recording. I'm going to use 11g and another 11g and a 13 and a 13. There are 0 g's in the middle. So that tells me that one of these is going to be a positive and one's going to be a negative. And that's what's going to make my middle term cancel out. Now, as always, I'm going to do a quick check mentally. 11 times 11 is 121 g squared. That's good. That gives me a negative. Actually, I don't even know what that is. But I know that's going to be a positive of the same thing, and they're going to cancel out. I mean, 13 times 11 is the same thing as 13 times 11. One's negative, one's positive. They're going to cancel. I don't even care what they are. They're going to cancel, and I'm going to get 0 g's in the middle. And then a positive 13 times by a negative 13 is negative 169. So that is my answer. That is what we get if we factor letter D. And hopefully you got the same thing. Okay, another one for me. Let's see here. Those are both perfect squares. Factors of that can square root to be 4, that can square root to be 6. So that's what I'm going to try first. 4u and 6, 4u and 6. One's probably going to be a plus and one's going to be a minus, which is how my middle term, notice there's 0 u's in the middle, my middle term will cancel out. So now I'm just quickly checking the math in my head. 4u times 4u is 16u squared. I like it. That is a negative 24u, and that is a positive 24u, and they cancel out, which is how we get 0 u's in the middle. Positive 6 times negative 6 is negative 36, and we got it. Okay, so that's it for mine. Here's letter F for you. Go ahead and pause the video. Do it on your own right now. All right, so both of those are perfect squares. 6 times 6, 1 times 1. That's what I would try. And notice there are 0 k's in the middle. So 6k and 1, 6k and 1, probably a positive and a negative, because that's what would make your middle term cancel out. 6 times 6 is 36k squared. Negative 6k, positive 6k, cancels, gets to 0. Positive 1 times negative 1 is negative 1. And we're good. That's done. See, isn't it nice when the same method you've been using continues to work and you don't have to remember another method, another process? My guess you've got 3 more. There's going to be these 2, and I think there's going to be 1 more after this. So why don't you go ahead and pause the video, try these 2 on your own. When you're ready to continue, hit play, and we'll go through them together. All right. So depending on how you divided, depending on what you factored out, this could have been a little easier, a little harder. I would like to make, since these numbers are both 12s, I'd like to make them perfect squares. So I'm thinking, like, if I divide both of them by 4, I would, I meant the other way around. If I factor out a 3, I would get a 4h squared minus 4. And those are still both perfect squares, or they are perfect squares now. They weren't. And that would mean that it would be 3 and 2h2, 2h2, one's a plus and one's a minus. I'm taking a good stab at this. I didn't actually run through the math yet. I'm pretty sure this will work though. So this is me checking. That is a 4h squared. We're good. That is a positive 2h. That is a negative 2h. They cancel. We're good. There's a 0h right here in the middle. This is a negative 4. We're good. So there we have factored this. And now as I'm thinking about it, I don't think there's anything else you really could have. I lied. You could have factored out a 6. I'm actually looking. I could factor out a 2 from here and a 2 from here. So I could have factored out a 6 and had 2h squared minus 2, except those aren't perfect squares. That'd be hard to factor. I could have factored out a 12 and 1h squared minus 1, those are perfect squares, and we'd get 12h minus 1 and h plus 1. That's a 1, not an L. This is actually equivalent to this. If you would imagine me factoring a 2 out of both of these, pulling him out. Factoring a 2 out of both of these and pulling it out, we would actually get that as well. So we have a couple different answers, and I don't necessarily think one is better than the other right now. Letter H was much easier though, because, well, those are both perfect squares. That's a 1, which is 1 and 1. That's a 49, which is 7 times 7. So my factors are going to be R7, R7. To make my middle term cancel, since there are no R's in the middle, that's not the word or, that's 0 R's. We'd have a plus 7, oopsie, and a minus 7. So that a positive 7R and our negative 7R cancel. And we're done. So quick and easy once you got the hang of this. Now my guess is there's one more on the next page. Oh, we're moving on to the next type. Okay, so these are trinomials. Now, you'll notice your first term, or my first term and my last term, are still perfect squares. 1, 16. So, again, it's okay that the middle term is not a perfect square. The hint is the first and the last terms are perfect squares. But even if you don't catch that they're both perfect squares, if I'm listing the factors of 16, 1 and 16, 2 and 8, 4 and 4, I'm going to try that pair anyways first. It's going to work out here. The only factors of 1 are 1 and 1. So, what do we got here? X and X, 4 and 4. Look familiar, right? We've been doing this for days. This is a 4x. This is a 4x. Can this give us an 8x? Why, yes. It can give us a negative 8x if both of those are negative. Minus, minus. So I've factored. Now we can actually pretty up our solution, or not solution, our answer a little bit. Our factors here are x minus 4 times x minus 4. That is x minus 4 squared. It's this thing times by itself. So this thing squared. That's what we're going to want to say for our answer. Okay, so it's the same as what we've been doing. Both the 4 and the 9 are perfect squares. If you didn't see that they're perfect squares, factors are 1 and 9, 3 and 3. I would try that anyway. Factors are 1 and 4, 2 and 2. I would try that anyway. So 2x, 2x, 3 and 3. Okay, let's see what happens. That's a 6x, that's a 6x. To make this become a negative 12, these would both need to be negative 6's, which means these would both be minus 3's. And now I'm just going to check to make sure everything works out. I think this is good. 2x times 2x is 4x squared. My middle terms, negative 6x, does give us negative 12x. My last term, negative 3 times negative 3 is positive 9. And we got it. That's our answer. All right. Letters C and D. Now, letter C is kind of like one of the previous problems we did, where there is both the first and last terms are not perfect squares. But I notice each of those three numbers are all divisible by 3. They're all multiples of 3. And when I do that, I get that. So I factored a 3 out of each of them. Divide by 3, divide by 3, divide by 3. As a result, 9 and 4 are both perfect squares. We'll call it a happy coincidence. And that means that when I'm factoring, the pair that I would try first anyways for the factors of 9 would be 3x and 3x. The factors I'd try for 4 first anyways would be 2 and 2. And so now there's a 6x, there's another 6x, which can give us negative 12 if they're both negative. And everything works out. 3x times 3x is 9x squared. Negative 2 times negative 2 is a positive 4. My middle terms work out, and we are all good. Oopsie, get out of here. And there's our answer. Okay. So, I've done a bunch now. So why don't you try one? I'm going to make this a little bigger. Go ahead and try letter D right now. See if you can factor that. All right, so let's see. We got factors of G are just 1 and 1. Factors of 25 are 5 and 5. So G, 5, 5. This is a 5G. That's a 5G. To make a positive 10, both of those would need to be positives. And I double check. G and G is G squared. Good. My middle terms work out. And positive 5 times positive 5 is positive 25. We got it. Okay. E looks fine. I mean, the first and last terms are both perfect squares. So the factors I would try first would be 3 and 3 and 4 and 4 anyways. So 3b and 4, 3b and 4. And you know what I just realized? In the past, like 4 or 5 problems, I didn't rewrite 3x minus 2 squared. G plus 5 squared. I forgot to do that. That's I don't know if I'd call it the better answer. I don't know if it's better. 2x minus 3 squared. They're equivalent. I think you're more likely to see this as an answer than this because it's more condensed. So I wanted to make sure that we talked about that. I've forgotten the past few problems. So back to this. Well, that's a 12b. That's a 12b. That's not RB. 12b. To make a positive 24, these would both need to be positive 12s, which makes pluses everywhere. And I'm going to do a quick check of the math. 3 times 3 is 9, 4 times 4 is 16, and my middle terms work out. So we're going to say this is 3b plus 4 squared. That's the answer we want to use. Okay, your turn to try. Go ahead and pause the video and do this problem on your own right now. All right, so I would try 7 and 7. I would try 2 and 2. 2w, 2w, 7 and 7. See, because these numbers are both perfect squares, it allows us to skip some of the other work like listing factors. Like we can be more sure it's going to be this pair. We can't guarantee it, but I can be fairly sure. 14w. 14w. To make it a positive 28, both 14s would need to be pluses, positives. And a quick little mental math check. Good there. 7 times 7 is positive 49 is good. Our middle terms work out. We got it. So now the solution would be 2w plus 7 squared. Okay, letters G and H. Why don't you go ahead and pause the video right now and give them a shot. All right, so let's see here. We've got both perfect squares, 4b and 3, 4b and 3. That gives me a 12b. That gives me a 12b. To get a negative 24, they would both need to be negatives, which make those both minuses. And a quick check. Everything looks good. Negative 3 times negative 3 is positive 9. So 4b minus 3 squared, highlighter, is our answer. Letter H. Both are perfect squares. 9 times 9, 5 times 5. So I would try 5m and 9. 5m and 9. There's a 45m and another one. To get a negative 90, these would both need to be minuses. And quick check the math. 5m times 5m is 25m. My middle terms work out. My last terms, negative 9 times negative 9, is positive 81. 5m minus 9 squared. Now you could probably guess what the next step of this process is. It's been the same last type of problem for a bunch of these. Would be probably going to solve an equation. I'm going to take a guess. We're going to solve an equation. So now what's different? Well, the only difference is after we get done with factoring, we have factor set equal to 0. We use the zero product property, and we just solve. Okay, so let's do it. Same amount of work. I'm gonna move everything over to the left hand side. So I'm gonna add 28m and add 34 to both sides. So I'm gonna have something equals 0. That's gonna be a 4m squared plus 28m plus 34 and 15 is 49. That continues to follow the pattern that we have been doing. Both 4 and 49 are perfect squares. So I'm going to take a stab that it's 2m7. Notice I'm not quite sure what the sign is yet. I always hang on to that until I've worked through it. 14m and 14m. And you probably could do this stuff in your heads now. To make it a positive 28, these would both be pluses. And a quick mental math check. Make sure everything looks good. Yep. 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 All right. So we've done that. Zero product property. Well, wouldn't it be kind of dumb to solve this equation twice? It's the exact same thing. I'm going to solve it once. Minus 7 on both sides. 2m equals negative 7. Divide, and m equals negative 7 over 2. So we actually only got one answer here. One solution. Where in all the other previous problems we got 2, this only has one solution. Letter B. This one is one of those guys that it doesn't have a middle term. There's 0 p's in the middle, not OP, it's not overpowered, it's 0 p's. So also, if I'm going to rewrite this guy, I'm noticing that my first and last terms are not perfect squares, which is fine. I can factor like it is. But I also notice that 18 and 72 have a common factor that I can divide away. I can make these numbers smaller, just makes it easier to factor. I'm not sure if 72 divides by 18. Exactly. I know it divides by 6. Ooh, it does divide by 18. Check that out. Okay, so if I divide everything by 18, my goodness, look how easy this is going to become. There, maybe we'll make him a ghost. There. So I have p squared minus 4 equals 0. So p and p, 2 and 2. 2 times 2 is 4. To make my middle term cancel out, one of these is going to be a positive and one should be a negative. And that would make this become a positive 2p and a negative 2p. P times p is p squared. Positive 2 times negative 2 is negative 4. Everything is good. So when we solve, we have p plus 2 equals 0 and p minus 2 equals 0. Solving both, p either equals a negative 2 on the left or p equals positive 2 on the right. Okay, 2 for me, 1 for you. Go ahead and pause the video and try this on your own right now. Alright, so let's see. Add 15m squared to both sides. He becomes a 25m squared. We're going to add 20m to both sides. And that little 4 dude just kind of comes along for the ride. Alright, I see that these are both perfect squares, 25 and 4. So that would I would guess, it's going to be a 5m and a 2. Not positive, but I'm pretty certain. And to check out the middle term, since this would be a 10m and then another 10m to make a positive 20, these would both be pluses. And doing a quick check of the math, 5 times 5 is 25m squared. My middle terms did work before I deleted them. See, there they are. Positive 10 and positive 10 was positive 20. 2 times 2 is 4. I can solve. I'm only going to solve one side because solving two sides here is not smart. Minus 2 on both sides. Not smart's not the right word. Solving both sides is redundant. It's extra work you don't need to do. It's not working smart. There we go. That's a much better way of saying that. Circle's a little bad. There we go. Applications. A man dropped a bowling ball from the top of a 25-foot building. After how many seconds does the ball hit the ground? Okay. In a real life scenario, do you know how long it would take? You can figure it out. This is actual honest to goodness physics math right here. Like, we could figure this out. So let's see. Final height. Well, the ball's hitting the ground. 0. T, time. How many seconds? We don't know. We're going to leave T. Initial velocity. If he's dropping the ball, when he first lets go of the ball, what's the velocity? How, is he like giving it a push? Is it moving at all? The answer is actually the initial velocity is going to be 0. He's not throwing it down. He's not throwing it up. It doesn't have a speed. As soon as you're holding on to something and you let go, that first like 1/1,000,000th of a second, it's just the thing just hangs there in air for a second until gravity starts pulling it down. There is no velocity. But our starting height is 25 feet. So I'm going to get rid of my middle term, that 0t. I don't need him. I probably should put my plus back. Now, if I was solving this, I would do one thing first. I would divide by -1 because I don't like this negative on my first term. I don't know if it makes the factoring any easier, but I don't like having a negative on my first term. So now I would get, or I would take a hazard at 4t and 5 because they're both perfect squares. Not guaranteed. That's just my first guess. My gut instinct tells me that's probably what it's going to be. This is a 20t. That's a 20t. And we want our middle term to be 0. So one would need to be a positive and the other would need to be a negative. Double checking my math. 4t is 16t squared. That's good. My middle terms cancel out. Good. My last terms do give me a -25. All right, that's all good. So in the solving, 4t plus 5 equals 0 or 4t minus 5 equals 0. Minus 5 on both sides. 4t equals -5. I'm running out of space. Let's scooch everything up a little bit. There we go. And that gives us t equals -5/4. I don't think that's going to be the right one. I don't think it's going to hit the ground after -5/4 of a second. On the other side, when we add 5, 4t equals 5, divide by 4, and we get t equals a +5/4. I'm going to guess it's that one. That's when the ball would hit the bowling ball would hit the ground after 1.25 seconds, 5/4 seconds. So I got two answers. One did not make sense. The other did make sense. So that's our answer. And summary. How does knowing special patterns help you solve equations? Like what little shortcuts and tricks were we able to do because of recognizing these special patterns? Think about it. Sorry for killing your ears. It's loud for me too. All right. Well, knowing things like here, like the fact that these are both perfect squares allows you to kind of shortcut listing out all of your factors. You can take a stab that it's going to be, the square root of that 3, the number times by itself. You can take a guess it's going to be that right away. Now, you're not guaranteed that that's going to work, but it works a lot of the time. Okay, so knowing that special pattern, that little trick, can save you a lot of time instead of listing out tons of factors and solving. And that's really what it comes down to. That's what this lesson was supposed to show you, is how you can shortcut this process a little bit. Okay, thank you so much for watching. Until next time, toodles.